So thanks, everyone. And I can say good afternoon since he's a few minutes late, so it's already afternoon now. So many thanks for the Linux Foundation and for the SONiC community for organizing such a workshop. My name is Ahmed Abdelsalam. I work in Cisco system and as part of the segment routing team. And today I'm going to talk about SRv6 microSID in SONiC. I heard three questions that come during the previous presentation. The first one is it standard? The second is basically, is it deployed in production? And the third one, is it in mainstream or mainline SONiC? So I'm going to talk to you about the technology that exactly has this, the answer yes to these three questions. So I saw a lot of people, we love SONiC. Some people said we love networking, and we love IP. So we all use the IP protocol all of the time. When you stream music, it's over IP. When you access your workload, it's over IP. But the problem is that over the last year, the industry has defined a lot of shim layers on top of the IP protocol. So we defined MPLS in the transport to deliver services like VPN, traffic engineering. We defined VXLAN in the data center to do data center networking. We defined the NSH in the NFV domain to deliver NFV networking. And everyone was convinced that the IP protocol cannot deliver all of this service by itself. It needs a shim layer. So in Cisco and in the team where I belong to, which is called the segment routing team, we had a mission to strengthen the IP protocol. Basically to make the IP protocol self-sufficient and able to deliver all of these services end-to-end across all of the domain because it's IP and we have IP everywhere. And being able to deliver all of these services, VPN, overlay, traffic engineering, NFV, data center networking without any shim layer. Because one thing that about this shim layer or those different protocols that you have in the different parts of the network, that you really need an expensive and complex gateway. Whenever your packet has to leave the data center and go to the transport, you need a gateway that will translate from VXLAN to MPLS. And because of the complexity of those gateways, you get a lot of scale and reliability issues. But using only IP and removing all of these gateways, you get better scale and better reliability. And this is basically what is SRv6. So it's a solution that gives you, using IP protocol, allow you to deliver any service across any domain without the need for any new protocol or any shim layer. And we will see in details how we achieve this. The second part of that mission to strengthen the IP protocol is basically to have the measurement integrated. In the past, you create the service, you deliver the service, but you don't know how to measure it, or you don't know if it worked as expected or not. The second part of that mission was basically to have the IP measurement integrated into the IP protocol, and this is what is called IPM. Today, I will focus only on the first part, which is SRv6 microSID, but I invite you to join another session that we will have at the SONiC workshop at OCP next month to talk about IPM and how we can do the measurement without the need for any extension or any shim layer, or even without the need for external probing appliance. What is SRv6? And let me explain you with very quickly and with an intuitive way how SRv6 work by showing the lifetime of a packet in a network. At the egress of the network, which can be your top of rack, your ingress PE, it can be the host, the customer packet is going to be encapsulated with an outer IPv6 header. Once the packet is encapsulated, the packet travels across the SRv6 domain using that outer IPv6 header, which means the customer packet is never touched. We deliver the customer packet as it is. We never touch the customer packet. At the egress edge, this customer packet is going to be decapsulated. So we remove the outer encapsulation, and we deliver the packet to the application or the customer. And what is special about this outer IPv6 header? How can we deliver all of these service or all of these promises that I show you in the previous slide using just the outer destination address? In IPv6, destination address is 128-bit. And in this 128-bit, how we use them? The first 32 bits is called the SRv6 block. It's an IPv6 block. It can be from your public space. It can be from the private space. The IETF has already allocated a specific block for SRv6. And in the remaining bits of the IPv6 destination address, we can encode up to 6 SRv6 microSID instructions. And those instructions can be bound to anything. So in this microSID from 1 to 6, I can have any instruction. I can have traffic engineering. I can encode my NFV, and then encode my VPN. And by adding all of this with a simple IPv6 encapsulation, you can achieve all of the use cases because you can bound that microSID instruction to any behavior. And with just a single IPv6 encapsulation, you can get up to 6 micro instructions. In MPLS, for example, after 25 years, most of the use cases actually requires less than 6 MPLS labels. So you can achieve the same just with IPv6 encapsulation. By having all of this integrated in the destination address, you can basically deliver any service. You can name it. You can bound the behavior to anything. And you can deliver this across any domain, from the access to the metro, to the data center, to the core, because it's IP and IP everywhere. And what is very important, that this is completely stateless, and you don't need anymore your expensive gateways that you have between the transport and the data center. When we started this project several years back, we had a strong and very key commitment to the customers. Basically, is to deliver something standard and very rich ecosystem both from vendor and open source. Here you can see the ecosystem of SRv6 microSID. You have all of the major network vendor. You have all of the merchant silicon. You have all of the open source networking stack, including SONiC, all of the open source stack, SmartNIC, you can name it here. Then from a standardization viewpoint, every single bit of that solution is already standard. You can see the list of the RFCs of the solution, from the architecture to data plane, control plane. It's all standardized, and we had a strong commitment for the SRv6 standardization, and we are co-author of 100% of these RFCs. The theme for the technology is basically simplicity. We want to make things simple. We just use a simple IPv6 encapsulation to deliver everything that you need. And this is the result of the simplicity. We have 5 years of public deployment across all of the network segments. You can see here from hyperscalers to service provider, enterprise, a data center, and across all of the different geographies. Right now, there is more than 80,000 routers in production running SRv6. And if you want to know why all of these operators are choosing SRv6 for their deployment with the factual data, I invite you to watch the recording of this. So in the first recording, Dan Voyer, the fellow from Bell Canada, he talked about why they choose to move from MPLS to SRv6 in the transport and what are the benefits. From the data center viewpoint, Guillaume Meshra from Verizon talks about the benefits of SRv6 compared to VXLAN in the data center. Eddie Ruan from Alibaba talks about the SRv6 deployment at Alibaba, and this is very interesting because it's with SONiC. And Rakuten also talks about the benefits of deploying SRv6 into their networks. All of these presentations are public, and I leave you the link in the presentation. Then why SRv6 microSID? And I will focus more on the data center application. Why I need to use SRv6 in the data center, what I gain by using it, and what it can deliver that I cannot achieve with other technologies. So before actually doing comparison or showing how it works, I want to remind you with something very important. It's the only solution that can allow you to deliver end-to-end service. No need for gateways, and without having to all of the shim layer that you need in the past. It outperforms all of the silo solution. This is factual, with factual data. If you look at the presentation that I left you in the previous slide, you will see all of the factual data points about this. Simple IPv6 encapsulation, you don't need anything more. And with this, you remove all of the unneeded complexity of gateways, etc. And the, how to say, the part that is very interesting, and we will talk more about this at the next OCP conference, is the integrated measurement. Then let's take an example of DC fabric and see how we can use SRv6 in that fabric. The very first thing that you want to deliver in a DC fabric is basically an overlay networking. So I want to send, I have a traffic, I want to deliver the traffic from top of rack 100 to the top of rack 200. As I said before, at the ingress, which here your top of rack, in some cases it can be actually from the host itself, I'm going to encapsulate the packet with just an IPv6 encapsulation. And in the destination address of this IPv6, we have the SRv6 block that we talked about, and we have the identifier for the top of rack 200. You can even read the destination address. Within this SRv6 domain, take this packet and deliver it to node 200. But let's say you want, on top of that overlay network, you want to deliver some kind of multi-tenancy or a VPN service. How I'm going to achieve this with SRv6? I just need to include the identifier of my VPN in the destination address. Again, you can still read the destination address. Within the SRv6 domain, go to node 200, where you have the VPN 145, and where you decapsulate the packet. And what is very key to know here is that this is completely stateless in the fabric. Any node in that fabric doesn't need to know anything about this VPN. They all forward the packet based on the classic IPv6 longest match. You do longest match based on the first 48 bits, and the packet gets up to node 200, and where you execute the VPN behavior. Then let's see how we would achieve this in the past. In SRv6, we said we need just IPv6 encapsulation. If you want to achieve the same with VXLAN, you would need 2 extra headers. Basically, you need a UDP header after IPv6, and then you need a VXLAN header, where most of these bits in the header are unused, except the VNI identifier that will identify, let's say, the VPN on the other side. So you can deliver basically, in order to deliver the same, you need 2 extra headers. And people who know the hardware here, they understand that parsing 2 headers or parsing 1 header is way, way simpler than parsing 3 headers. But then you may say, okay, you said that SRv6 can provide what other solution can provide, but just in a simple way. That's not true, because you can get much more. First, and I always remind it, is the end-to-end. You cannot get end-to-end with any other solution. When you have VXLAN in the data center, the moment that you need to leave the data center, you cannot leave the data center with the VXLAN encapsulation. You need the gateway, and you need to translate it. But more than that, let's assume, and this is an interesting use case because it comes from one of the very big hyperscalers, is that in some fabric, you have, based on, you want to avoid some nodes. So you have those red nodes, which is node number 2 and node number 5. You don't want your traffic for some specific flows to go over these nodes. How can you do this? With SRv6, it's very simple. What do you need to do is that you need to, in the destination address, we are still in the simple IPv6 encapsulation, just in the destination address, you can encode the path to avoid those nodes. So you can even read the destination. With an SRv6, go to node 4, then node 1, then go to node 6, and then you go to node 200, and basically you execute the VPN. So you can do also all sorts of traffic engineering that you need in the data center without the need to add any new header. So on an apple-to-apple comparison, SRv6 can provide exactly the same as what you have and much more with actually less overhead. So all of this is good. Is it ready? Is it already supported in the SONiC? Can I already deploy it? And the answer is yes, because it's already running in production at Alibaba, one of the hyperscaler. So, but before, let me show you a bit the journey, because it's a very good example of, let's say, ecosystem collaboration between many players in the SONiC in industry to get to this point. So in 2021, it's the year when we started the collaboration on SRv6 with Alibaba. So Cisco and Alibaba started the collaboration to bring SRv6 microSID in SONiC with many other key players in the industry. Exactly in the same year, we get SRv6 support in SI and SONiC. And then 1 year later, in 2022, is basically when Alibaba announced their Alibaba routing platform. It's basically a SONiC device with and it's SRv6 enabled. 1 year after, it's when the SRv6 was deployed in production in Alibaba across China, and together we wrote, how to say, a blog post on the Linux Foundation. You have the link for this. And we started the SONiC routing working group. This year, there is a very important initiative as well. It's called the PhoenixWing initiative. It started by Alibaba and has been endorsed by Cisco and all of the other key players in the industry. And this consists of two phases. The first phase is basically to bring all of the code deployed at Alibaba that is not yet open source to be in open source, and this is targeted for SONiC 2411. As a phase 2 of that project, it will be the IP measurement. A bit on the details for on the SRv6 support in SONiC. Starting from the SI, we have the SI header for SRv6. Basically support all of the behavior, including the encapsulation, the endpoint, and the traffic engineering. On our side in Cisco, we have the SI adapter that implement this fully this SI header, and it's already deployed at Alibaba. A bit on the details of the SI header, here is a list of the SRv6 behavior supported. These behaviors are defined and standardized in the RFC 8986, which defines the SRv6 network programming. And you have the links here for the high-level design and documentation of the SRv6 SI header. On the SONiC, all of these behaviors are supported across all of the different components: config DB, application DB, orchestration agent, etc., and also an FPM module that was extended for the integration with FRR. Here is few also pointers to the SRv6 support in SONiC, including the high-level design, the database schema, and all of the different tables that used by SRv6. We have defined, which is already merged in the mainline SONiC for many years now, a new orchestration agent called SRv6 that used to program this in the SDK, and we extended the FPM module and the FPM syncd for the integration with FRR. On the FRR side, which is a routing stack used by SONiC, we have a very solid SRv6 support. In the room here, you have one of the FRR maintainer. You can talk to him. He knows the code very well. So on the BGP side, we support SRv6 layer 3 VPN service for IPv4 and IPv6 address families. We support ISIS underlay with SRv6. And on the Zebra, we support a very, key components called SID manager, which basically you see this, you have seen when I show the destination address, your SIDs and how those SIDs are allocated. That component takes care of SID allocation for the different services, etc. And what is key is that it ensures full interoperability between SRv6 in SONiC and the SRv6 implementation of other vendors, including Cisco. And the allocation scheme used here by this SID manager is what was reported at the EANTC interoperability report this year. A bit of more pointers to, if you want to learn more about SRv6 and the deployment at Alibaba. So first you have the white paper written by Alibaba on their deployment. And here there is the blog post that we wrote together with Alibaba at the Linux Foundation. If you are looking at a demo of how SRv6 works in SONiC, here the link for the recording. We show an example layer 3 VPN with SRv6. And at the next OCP, we're going to have also a demo booth where we're going to show an SRv6 demo as well in SONiC. Then the SONiC working group, which is another good example of ecosystem, working in ecosystem to bring this feature. This started last year, and basically we have closer to 300 members, both coming from all of the key industry, player behind the SONiC, and with a very big expertise on the SONiC and FRR. The goal of that routing working group is to make SONiC really ready to be a router deployment, moving from just being a simple data center switch to an actual router. The initial focus of the routing group right now is SRv6 microSID, all of the communication between the FRR and SONiC, the BGP loading time to get the scale needed for the router, and other topics. The PhoenixWing initiative, this is something started this year, and it was announced in May this year. It's basically to bring the readiness of the SRv6 into, into SONiC 24.11, and this is something endorsed by all of the, SONiC key members, including Alibaba, Cisco, Microsoft, Broadcom, and the Linux Foundation. You have a link for the blog that was written about the PhoenixWing initiative. And if you want to see the endorsement videos from all the SONiC community members, here is the link for them. I don't know if I am late or on time, but a few minutes late. Just to conclude, SRv6 microSID makes IB self-sufficient and better than ever. You can deliver any kind of services, being VPN, traffic engineering, or whatever, across any domain with no need for any new protocol or shim layers or expensive gateways between the domains. And we have all of the factual data that shows how SRv6 outperforms these technologies, and this has been presented by operator, not even by us. It's fully standardized, and we have a very rich ecosystem, including SONiC. On the SONiC side, it is ready for deployment. It's already deployed in production at Alibaba. We have a very rich SONiC ecosystem, and you have two examples of that, of working in ecosystem, including the SONiC routing group and the PhoenixWing initiative. That, thank you, and if you have questions.